Hi, welcome to the Shiko Mathematics Statistical Problem Solving session. And today we are going to continue work on the maximum likelihood estimator. So today's problem is we have a sequence of the independent random variables from the normal distribution with mean is equal to mu and the variance equal to the sigma square. And in here, we define the M2 prime is the second moment. So for this problem, we're going to assume for this normal distribution, if mu equal to sigma, under this condition, what will be the MLE for mu? And from our previous video, we talk about is the same thing for the normal random variable, but that condition is when the mu is equal to the sigma square. So today we're going to take a look at when mu equal to sigma, what will be the MLE. Okay, so now let's go ahead, go to the whiteboard, and let's take a look at how are we going to solve this problem here. Okay, so here, okay, all right, so just okay, so just to kind of refresh what we did in the previous video. The previous video, we are assume under the condition. Okay, so if x1, x2, and xn, they're all from the normal distribution with the mean equal to mu and the sigma squares here. So our previous video we proved here. So this is the first part. We did this in the previous video. We say if mu equal to the sigma square, then the MLE for mu, we call this the mu hat. It will be the 2, and this is -1 plus the square roots of the 1 plus 4 m2 primes here, where the m2 prime is the second moment like we defined there. Okay, so today we are going to take a look at another part of this problem is the part 2 here. How about if the mu is equal to sigma, then what is the MLE for mu here? Okay, so let's go ahead, take a look here. So the first, let's write it down, what is our likely functions here, likelihood functions here. So this will be x1, x2, and xn. We know the PDF of the normal distribution, right? So these ones here will just be the square roots of the 2 pi and the nth power. And used to be here will be a sigmas, right? But now the sigma, oh, I'm sorry here. I need to be careful here. Is the mu equal to the sigma. So now because the sigma equal to mu, so I will write the mu to the nth powers here. And then this is e to the negative. Here will be the 2 sigma square. But now because mu is equal to the sigma, so this will be 2 mu square here. And then here will be summation xi minus mu to the square I from 1 to n here. So this is our likelihood function. So in order to solve this problem, there's a lot of just algebras involved. So we just need to be very careful about the algebras here. So let's take the log function for my likelihood functions here. Okay, so now in here we can say, let's put the ln natural log here, all right? So then here we take the natural log, it will be the n, then it's the natural log square root of the 2 pi, and then this term will be negative n natural log the mu, okay? Then here, this ln and e cancel out, so it will just be minus 2 mu square. and the summation x I, so I equal to, so this will be summation I from 1 to n xi minus mu to the squares here. Now, in order to find MLE, I need to take the derivatives, right? So it's ln, this likelihood function, and take the derivative respect to what? Respect to mu's here. Okay, so in here, okay, so the first term, this n log natural log square root of 2 pi is a constant, so it's cancel out, so it's 0. So the n, the natural log mu, so you take the derivative of mu will just be mu, and here is n, right? And then this is negative 1/2 here. 1/2 is here. Then the mu square, then I need to use what? I need to use the quotient rules, right? So quotient rule, this would be mu to the fourth. You square the bottom, then you hold the bottom, right? So you hold the bottom, so it would be mu square. Then take the derivative of the top here. So the derivative of top, so it will be 2. So you move this 2 to the front. And then this will be the summation I from 1 to n xi minus mu. And then the chain rule in front of the mu. So I have a negative here, right? So then minus, right? So minus what here? Minus you hold the top. So I from 1 to n xi minus mu the square. And the whole things take the derivative of the bottom, the mu square. So derivative of the bottom will be what? Will be 2 mu's here. Okay, so now I'm going to simplify. This is n over mu. So in here, I'm going to simplify a little bit. So make the calculation a little bit easier. Okay, so in here, both terms have 2 mu. So what I'm going to do here, I'm going to take the 2 mu out. Okay, so when I factor the 2 mu out, the first term, I have negative mu, and I have a summation xi minus mu. All right, so of course I from 1 to n. Then the second one, I take 2 mu out, so it's just a summation xi minus mu to the square. Okay, and then in here you can see this 2 and 2 and the mu, and they're going to cancel with this mu, so this will be 3, right? So 2 mu to 3. Okay, so now let's continue here. So this will be negative n to the mu, then this is the mu to the cube, okay? So now I'm going to do the inside. This is negative u times the summation x. So this will be negative u and the summation xi. Then I know the summation of the mu will be what? Will be n mu's, right? So this is a negative, negative is a positive. Now I will have positive n mu square. Okay, the reason why is because the summation xi minus mu, this will be equal to summation xi and the minus n mu, right? Because summation mu, that means you have n mu's there. All right, so then the next thing is here, the summation xi minus mu to the square, I want to put here. This one's here will be the summation xi square, right? Minus 2xi mu plus mu square. So this one will be the summation xi square. Then the mu minus 2. So here you can take the minus 2 mu, right? So this will be minus 2 mu summation xi. Okay, then plus n mu square. Okay, so now let's be careful about the negative sign. So this is minus the whole thing. So it's a minus summation xi squared, right? Then minus minus, it will be plus 2 mu, right? Summation xi. Then minus plus is a minus, so it's a minus n mu square. All right, let's try to cancel something. Oh, this is pretty good. N mu square, n mu square. And so here, this is a positive 2 mu summation x. This is negative. So this one and this one cancel. So it's only have a 1 mu summation xi there. That's right. Okay, so now we simplify that. So this will be the negative n, the mu minus mu cube. All right, and then this is minus mu cube. So I will have this is the mu summation xi, then minus summation xi squared. Okay. And then the next things here is just what? Just combine to find the common denominator. So the common denominator here is mu the cube. So the first term will have a negative n mu the what? This will be the negative n and the mu to the square. Okay. Then this will be minus mu summation xi, I from 1 to n, then minus minus is a plus, so it's a plus summation xi squared. So we know the MLE, then we will set this one equal to zeros, right? So if this one equal to 0, that means the top will be equal to 0. That means n mu square minus mu summation xi, I from 1 to n, plus summation xi square equal to 0. So let me just times the negative sign in front. So I will have n mu square plus mu summation xi, right? I from 1 to n, then minus summation xi squared. All right, so I will set this one equal to 0. Okay, so I set this one equal to 0. Then I will use quadratic formula to solve what? To solve for mu's, right? So okay, so we treat the mu is the constant. So mu is going to be, okay, so 2a. So this is going to be, this is the quadratic formula. This is going to be by a, this is going to be by b, and this is going to be by c, right? Okay, so it's a 2a, so it's a 2n. Okay, negative b. So the negative b is a negative summation xi, all right? Then plus, okay, so it's a plus or minus, okay? So it's a plus or minus summation, okay? The b square, so it's a summation xi, the whole thing square, minus 4ac. So minus, so it's a plus 4n times the summation xi squares here. Since in here we said conditions here is mu equal to sigma, so the negative sign not going to work, so we know it's only is the plus here. All right, so now in here, this one's here, so now I can find the, okay, so here, all right, so now I will divide by n both sides, like divided by n, so divided by n on the numerator and divided by n on the denominators here. So this is the numerator. I divided by n's here. It's a summation xi to the n. Then plus, like we talk about, right? So it's the because mu equal to sigma, we only take the positive one. So this is a summation, right? So it's 1 over n. So this is a summation of xi square plus 4n summation xi squares, right? Okay, so now here, the bottom here, right? So the bottom here and the n. Okay, so you got 2. That's good. And then in here, so this is the what? Summation x bar, summation x over n, that will be x bars, right? So this is a negative x bar. Okay, so now I need to bring this 1 over n in. So when I bring this 1 over n in, I bring in 1 over n squares, right? So I have 1 over n squared. So this will be 1 over n squared. I bring this in, so I have a summation xi, the whole thing square, plus 4n summation xi the squares here. So one more algebra. So this is a negative x bar plus in here. Okay, so the n square. So this will be the summation, then x, then I put the n squares here. So for the second term, if you times n square, so it's going to be what? 4 the n summation xi squared. Okay, so finally, we got our solutions here. Because the summation x divided by n, what is this one? This is x bars, right? And also, we just defined what is summation x squared divided by n. This is our second moment, right? So that's why we define this n2 primes here. So that is finally my answer is 2. This is a negative x bar plus, all right? So the negative x bar plus here, this is x bar to the square, then plus 4 the m2 primes here. So you can compare this one with our first part when the mu equal to sigma square. So this is what our first part, the MLE for mu hat. And this is when the mu equal to sigma, and this is our MLE for mu. So here it's very close, right? So so it's very interesting the problem. So you can see, when you're given the conditions, and one is mu equal to sigma square, and one is mu equal to sigma, and then their maximum likelihood estimate of the mean, it will be different. Okay, all right, that's it. And I hope that this help you to understand how to compute MLE better. All right, looking forward to talk to you in our next problem solving videos. Okay, bye-bye. Have a good day. Okay, bye.